3 sine of x along with these initial conditions. So basically, we're just finding an antiderivative twice. First, the antiderivative of y double prime will give us y prime, which the antiderivative of 3 sine of x is negative 3 cosine of x plus an arbitrary constant. But we'll use this initial condition right here to find out what that constant is. So when x is pi over 2, y prime is equal to 2. So let's kind of indent here and go this way. 2 equals negative 3 cosine of pi over 2 plus c. But the cosine of pi over 2 is 0, so this just becomes c equals 2. So therefore, y prime is negative 3 cosine of x plus 2. Now we find the antiderivative of this. Y equals, what's the antiderivative of negative 3 cosine of x? Well, it's negative 3 sine of x. Antiderivative of 2 with respect to x is 2x. And another arbitrary constant. I'll still use the letter c. And we're told that y of pi over 2 equals pi. That means when we put pi in for x, pi over 2 in for x, we get an answer of pi. So I'll indent again. We get a value of pi when x is pi over 2. So I'm putting pi over 2 in for x so that I can find the particular value of this arbitrary constant. The sine of pi over 2 is 1, so I've got pi equals negative 3 plus 2 times pi over 2 is pi plus c. I can subtract pi from both sides, add 3 to both sides, and I finally get c equals 3. So there is your particular solution. Y equals negative 3 sine of x plus 2x plus 3. And of course, you can double check your work by taking derivatives and see if we end up with this. Let's just do that real quick. Y prime equals, derivative of sine is cosine, so negative 3 cosine of x plus 2, and y double prime equals, the derivative of cosine is negative sine. Negative 3 times negative sine is 3 sine of x. So indeed, this is a particular solution for this. Okay, I'll stop recording and hope you understood that.